In this video, we're going to take a look at standard free energy of formation and how we can use these values to calculate a delta G value for a chemical system. Now, starting with the definition, the standard free energy of formation, or delta G with the subscript F naught, is the free energy change for formation of 1 mole of a substance in its standard state from the most stable form of its constituent elements in their standard states. Essentially, you can look up delta G formation values for pretty much any particular chemical substance out there. So this can be really helpful. You can go to data tables, get delta G values, and then, or delta G of formation values, and then you can calculate the delta G of a system by taking the sum of the delta G of formation of the products minus the reactants. So again, very similar to other calculations of the same sort of nature that we've seen here. Now let's take a look at an example. How do we use this? So this question is asking us to calculate the standard free energy change for the reduction of iron 3 oxide by carbon monoxide given by this equation here. And we're given delta G of formation values in this data table. So to find the delta G of this reaction, because that's what we're trying to do, we're going to take the sum of all the delta G of, oh my goodness, can't write this. Okay, delta G of formation of the products minus the sum of the delta G of formation of the reactants. Okay. We do need to consider the number of moles of each, so we do have to be careful as we're putting that in. So let's start with our products. We got 2 irons, and the delta G of formation of iron is 0. I'm just going to put this in just for sake of clarity here. And then we've also got our other product, CO2, and we've got 3 of those times CO2 is negative 394.4. Okay, so we're going to add those two together, and then we're going to subtract all of the reactants. So our reactants, we have 1 of the iron 3 oxide, which is negative 742.2. And then we've got 3 carbon monoxide. So 3 times negative 137.2. Okay. Oh, we're just squeezing that in there. All right, so if we do that calculation, again, we're adding these up and then we're subtracting those added up. We get, and then rounding for sig digs, we're going to get negative 29.4 kilojoules per mole. Everything's in kilojoules per mole here, so that's what our units of our final answer are also going to be. And because everything has 1 decimal place, our rules for sig digs tell us that we should also have an answer to 1 decimal place. Now, negative value here means that this reaction would be spontaneous. And so that's a nice way for us to determine spontaneity of a reaction just by using data tables of delta G values of formation for the different substances. That's it then for this video. We'll see you in the next one.